Okay, we're going to take a look at Unit 2 assessment. Okay, Unit 2 assessment. So we're going to click on our assessment, and you're going to notice that it's going to give you a list of the problems that you're going to be working for this assessment and the points associated with them. So what I wanted to do was go over each one of these problems and see if there's any initial questions, but just want to give you an overview of what the assessment is all about. So first and foremost, all of these problems are coming out of the McGraw-Hill ebook, not out of the handout or anything like that. They're all out of your e-textbook, the McGraw-Hill. This assessment is going to cover modules 4, 5, and 6. And what I did was you'll kind of notice I pulled problems from each one of those sections. Okay, so the first module that we looked at was module 4 here for this assessment, and it was a resultant of non-concurrent forces in a plane. This was where we got introduced to the concept of a moment. Okay, and we actually used the handout out of the other textbook that I used to use. But for this problem, this one's coming out of the McGraw-Hill ebook. So this problem that pertains to this section is going to be problem 3.5A and part A only. And this is found on page 97 in your ebook. This is going to be worth 10 points. So I'm going to go underneath my camera here. And I have page 97, okay, in the problems. And this is going to be problem number 5. Problem number 5. So I'm going to zoom in here. We'll look at it. It says we have a 300 Newton force acting at this 25-degree angle, as shown. We want to, now remember, part A only. We want to determine the moment of that 300 Newton force about D. So there is an illustration here, or I'm sorry, an illustration. There is a pivot point here at D. We've got 300 Newton force at an angle. So it looks like you probably want to break something into components, right? And all you want to do is determine what is the moment about point D that creates. That's it. Okay. So just part A for this one, that's worth 10 points. 10 points. If you need to go back to module 4 and kind of refresh yourself, then, feel free to do that. But we've been working quite a bit and working with moments. It should be pretty standard. Okay. So that's that. But if you do have questions, don't hesitate to ask. Going back over here. So that's our first one. The second one, this was module 5, equilibrium of rigid bodies. So this is going to be looking at problem 429 on page 183. Again, in the McGraw-Hill text. And this one, okay, is down here at the bottom of page 183, problem 429. We have a 12-foot wooden beam. It weighs 80 pounds. So you're going to notice that they're showing that weight going down. It is supported by a pin reaction at A and a cable at B. Find the reaction at A and the tension in the cable. So the body we're worried about here is just this beam. And there's a support here, a pin support at A and a cable at B. I want to know what the tension in that cable is, and I want to know what the reactions at A are. Okay. So so that's your next problem. Going back over here. The next 3 problems are going to come out of chapter 6, again in your McGraw-Hill book. The first one's going to be a truss problem. The next one's going to be a frame problem. And the last one is going to be a machine problem. Okay, so let's look at page 288, problem 6.1. So underneath here, problem 6.1 on page 288. Okay. This is going to be the truss that you need to work manually. Okay. You don't need to do MD solids if you don't want to. Okay. You don't have to, and you don't have to hand in a screenshot or anything, but you will work manually, and you're going to determine what are the forces in each one of these members. Okay. And this is a standard truss problem. So what I would suggest that you do is you do run MD solids. Again, you don't have to show it to me. You don't have to take a screenshot or anything, but by running MD solids, that would give you, if you would, your answers. Okay. Now, you'll notice that there aren't, if you would, it's not obvious that there's even increments down here, but there are. Okay. So you'll notice that you have 3 meters and you have 4.5 meters. 1.5 meters goes into each one of these. So if you break this in half, that would be 1.5. And if you break this into thirds, that'll be, each one of these sections would be 1.5 meters. Okay. So when you set up your grid, you're going to have 1.1, 2, 3, 4, 5 sections horizontally of 1.5. And then you're going to have one section vertically of 4 meters. And then what you can do is you can put your members in as you see here. Okay. So I just wanted to point that out because it's a little bit different than setting up the ones that we did, because they all had obvious like even increments across horizontally or vertically. This one has it, but it's not as obvious. So I wanted to show you that. Okay. So that is going to be your truss problem. So in this case, there's only 3 joints that you have to do. I tried to pick something that was a little, not so involved. So that should help you out a little bit manual calculations wise, but then you can still show me how, and impress me with your truss ability. So that's the truss problem. The next one that we have here is 671, and this is on page 316. It's going to be our frame problem, but it's actually a truck and a trailer. So if we go underneath, 671 is your problem. And you'll notice that you have a truck, you have a trailer, and it's really essentially the very same problem. This is the one, right? Yeah, 71. This is the same problem that we did in our handout, but truck was on this side, the trailer was on this side, and you have some different numbers that you're working with. Now, in this case, they're asking determine the reactions at the wheels and the additional load on each of the truck wheels due to the trailer. This means the tongue weight. Okay, so what you want to know is what is the reaction at D that's putting the load on the truck. Okay, and that's going to be the tongue weight. So it's the same problem that we did for your homework, except they're using just a little bit different terminology in that second part. Okay, so as you remember, D is considered an internal pin. So when you're showing it as a frame, in quotes, a frame together to determine the reactions at the supports, you're going to find that you're not going to be putting D in there. That's just a connection. But when you break it into its separate members, the truck and the trailer, then you will have to put D as a point, and then changing the direction when you get its magnitude from one member to the other. Okay. So again, just like that problem that we did, except different numbers. Okay. And then lastly, we're going to do 685. This is found on page 322. And this one is going to be a pliers. Okay, this one's going to be a pliers. And in this case, what you want to do is, given the information here, you want to determine the magnitude of the force exerted on the rod. Here's the rod. Okay. Now I want you to note something, that this surface that it's up against is right here. Okay. So the actual force on the rod is going to be perpendicular to that surface, and you're given the perpendicular distance already from A. Okay. So there's more there than what you may think. And then you also want to know that what the force is exerted on the pin. Okay, and that's going to be pin A. So because it's a pin, it's going to have an X and a Y reaction. Okay. So very similar to our problem, just a little bit of a difference just because of the surface that rod is, that rod is actually up against, it's going to be at that angle, okay? But you have a perpendicular distance, so it's pretty straightforward. But if you have any questions or concerns as you're working it, let me know. Now, something I want to let you know is that all but one of the problems, the answers are provided for you in the back of the book or in the appendix, and that was by design. The only one that is not a blue problem, so anything that's a blue colored problem has the answers in the appendix. The problem 671 was a red problem. Okay, that one, the answers are in the back of the book. So you're just gonna have to go with that. I'm not gonna give you the final answers, but the rest you do have the answers for, okay? Now, something I wanna let you know is, for instance, this might happen in more than one place. On problem 429, for instance, problem 429, I'm gonna go underneath here. You will have an X and a Y reaction at A because it's a pin. But in the appendix, they're going to give you the resultant force of the X and the Y. So for instance, on that one, on A, so point A is going to have it, and I don't know the directions and I don't know the magnitudes. So don't take this for anything but what it is here. You're going to have an X and a Y reaction at A. They are going to give you, if you would, and again, I don't know if this is the right directions, they're going to give you a value of A. So instead of having an X and a Y at A, they're going to just have the resultant of those two. This resultant is the hypotenuse of a right triangle because this is the equivalent length over here. So A is going to be equal to the square root of AX squared plus AY squared. And so that value for A is going to be that. Now, you don't have to take it that far, but as a check to see if your X and your Y values are correct, put them in and find the hypotenuse. And if that hypotenuse matches the answer in the back of the book, you know you did it correctly. If your hypotenuse does not match the back of the book, then you know something wasn't right. So then you can go back and you can check, okay? Now, they're also going to give you, for instance, the angle that it's at, okay? You don't have to do these two. You don't have to figure these two out. You can leave them in your AX and their AY form, and your check will be just putting it into the Pythagorean's theorem to see if your hypotenuse matches what they have, okay? And that might happen in a couple instances for the answers that they're giving in the back of the book. All right. So I wanted to point that out because I never had you go that extra step because X and a Y, you know, so that's how I always had students do it. So, so when you reference the back of the book, it's just going to be a slightly different, but essentially the same. Okay. So, so that's what I wanted to let you know about assessment, unit assessment number 2. Are there any questions just at the moment as we kind of went through and glanced at it? I'll watch the chat. Not seeing anything, or verbally, feel free to just shout out your question. Okay. Not seeing anything. So what I'm going to do is I'm going to stop recording.